This video is a linear programming example for exceeds expectations. So that means that it has all three parts of the linear programming. And you will need to write the problem understanding, write the constraints, inequalities, and the objective function max or min. And to show your work, create a table with the information given and identify the variables. So if you try this and say you don't get the right constraints at all, but then you go on to do the feasibility and boundaries and the solution, and you are correct by what you had up here, you will get the points for the feasibility and the solution. Okay, so it doesn't hurt to try it. This is so that you can exceed in the expectations of the standards instead of just meeting the standards. So a higher percentage grade. Okay, so we are using the whole rubric for these kind of problems where you are scored on the constraints, inequalities, and objective function, and you're scored on the graphing the constraints and the identify the critical points and identifying the mathematical solution using the critical points, writing the solutions to the questions asked in the word problem. Okay. So our problem that we're going to solve is Thomas needs to plan out his dog Robo's food. Robo needs at least 30 grams of protein per day. Food A supplies 2 grams of protein per ounce, while food B supplies 6 grams of protein per ounce. Robo also needs 16 grams of fat per day. Food A supplies 4 grams of fat per ounce, while food B supplies 2 grams of fat per ounce. Robo cannot eat more than 12 ounces of food per day. Thomas would like to be as cost-effective as possible with Robo's food while he's still meeting his dietary requirements. If food A costs 8 cents per ounce and food B costs 26 cents per ounce, what combination of food is the least expensive? So we got food A and we have food B. And since the question, I like to write down the question, just copy the bottom half so that I know what my variables are going to be, food A and food B. And then when I'm looking for the maximum or minimum, it's least expensive, so I'm looking for the minimum because that's a smaller amount. And then the cost per one is part of my objective function. Okay, so the cost, 8 cents for food A times the X value, which would be food A, and then 26 cents times the Y value, which would be food B, and that would be my objective function, and then the smallest amount that I get in there from my critical points would be my answer. Okay, Thomas needs to plan out his dog Robo's food. Robo needs at least 30 grams of protein per day. So when I'm building my table, I'm going to be looking at protein, and I'm going to be also looking at fat. Okay, so protein and fat, the pink and the orangish, and then I have the blue for the X and the purple for the Y. Okay, except I made food A here pink, and it should be blue. I apologize for that. Okay, so I copied this onto here, and then I went into making my table. So food A is the X, food B is the Y, and then I have grams of protein, and it says that he needs at least 30 grams, so that's greater than or equal to 30, because at least means 30 is the lowest he needs. Okay, and So I have food A supplies 2 grams of protein. So that would be 2 times X for food A. And then while food B supplies 6 grams of protein. So that would be 6 times Y for food B. Food B is Y, and it says 6 grams of protein per ounce. And then 16 grams of fat per day would be let's see. Robo also needs 16 grams of fat per day. So he can have at least 16 grams of fat. So it's got to be greater than or equal to 16 grams, the total. And then we have 4 grams of fat per ounce for food A. So that would be 4X. And then 2 grams of fat per ounce for food B. So that would be 2Y. Okay. And then it also does have in here, and I don't know if it was color-coded in the previous one, but Robo cannot eat more than 12 ounces of food per day. So the food A plus the food B has to be less than or equal to 12 ounces of food per day. Okay, the cost then, which is my objective function that I'd be writing from this, would be 8 cents for food A, so it's 8 cents times X, and 26 cents for food B, so that's 26Y. And that's the cost, that's what I want to minimize. So that's all in the question, always, which usually comes at the end, so I pulled it out. Okay, the next thing I do is I write my constraints from my table. So I have a 2x plus 6y is greater than or equal to 30, which is right over here. Oops, I keep doing that. I have a 4x plus 2y is greater than or equal to 16, and I have an x plus y is less than or equal to 12, okay? And then my objective function. I also have that x has to be greater than or equal to 0 because he's not going to have a negative ounce of food, okay? It's not going to have that. You want him to intake the food. So y is also greater than or equal to 0 because that would be food B. So it's counting. So that's always positive numbers. Okay, so now that I have my constraints and my objective function, I don't use my objective function until the end, but it comes from the problem, so it's nice to write it at the beginning. And then I have my constraints, which I need to go on to Desmos and put it in, and then take screenshots of what I get. So I did that in the next screen. Constraints graphed on Desmos and critical points labeled. So this is the second part of the problem for linear programming. And here's my constraints that I put into Desmos. And then here's my critical points. We have 0, 12 right here. This gets into the negative range. 0, 12. And so this is a border. 0, 8. And then 1.8 and 4, 4. Okay, and 10.5 and 1.5. This is a little dark here, kind of hard to see, but here is my feasible region. Okay, so I have 4 critical points, and then I'm going to take those and I'm going to plug them into my objective function. So I'm working on the third part right now. Identify the mathematical solution by using the critical points and write the solution. So the solution, I'm using my objective function, which I'm minimizing. So I'm looking for the smallest number that I get. So here's my objective function. I wrote it out for all of these, and I wrote down the critical points, and I substituted in the values for the points, the x's, and then the y's, and I computed it out, and my smallest amount is $1.23. So that would be the least expensive. So what combination of food is the least expensive? That comes from the question. So my answer is in words to answer the question. The minimal cost is $1.23 for a rowboat to have his dietary needs met. This is a combination of 10.5 ounces of food A and 1.5 ounces of food B per day. Okay, so I answered the question and we're all good to go.